Hey everyone. So today I thought I'd talk a little bit about how to work with Unity's character controller. What we'll be doing is we'll be building a very simple first-person style control scheme where we can move the camera around with our mouse and move in the direction that we're facing. It'll include some forward and backward movement and then also some strafing as well as like a very simple jump. So let's get started. So I've created a really basic scene here and just put a couple of things in this. And the one thing that I put that we haven't dealt with so far is a player, which is represented by a 3D primitive called a capsule. And so a lot of the character controller stuff is built around this kind of form. So it's often used as just a stand-in for us while we're prototyping or gray boxing. And so I'm going to work with a couple of scripts that we're going to build out together today. The scripts are a two-part kind of thing, so we're going to separate the movement out from the mouse looking. Part of that is because we could take the script that we're going to be developing for the movement and apply it to a third-person kind of control scheme as well. So I wanted to keep that open as well so we can build off that later on in the semester. So the first thing I'm going to do is I'm going to locate my player game object here, and I'm going to add a component to it. And the component I want to add is called a character controller. Now, Unity provides us with this component. It handles like really useful but simple things related to the movement of a character in your scene. It allows us to compensate for things like slopes, for little steps that we might encounter. It gives us a way of checking ground without having to add our own physics. It gives us kind of a number of things that we can deal with here. It does create like a really simple capsule collider for us to look at that we work with as a way of like understanding this relationship in the world that we have. Again, that's why we chose the collider here to represent our character in this example. Now, just adding this doesn't add any kind of control whatsoever. So by doing this, we're not able to actually move things around. We still have to write a script to somehow control this. I also want to point out that this character controller is one way that we can create movement. So up until this point, we've been dealing with rigid body as a way of creating movement in the world. We could still continue to do that and build out basically the same kind of system here, but only do it from the perspective of rigid body. And so this is just another way that we can access things and get things moving that I wanted to show you this semester as well. So let's hop in. I've started a script here which will control our player movement. So I'm just going to add this to my player now. And this will interact with my character controller. And so I'm going to open it up. Again, there's nothing in here. The first thing we need to do whenever we're interacting with a component that's added to our player's game object here is that we just want to get a reference to it. And so this one that we want today is character controller. So I'll just set it up like this. We don't need to set it in the inspector. It's already there for us. So we're just going to use get component as a way of populating this. So we're going to get that component that's connected to this game object down here and start. Again, we only need to do this once. Our character controller doesn't change throughout the game. So if it did, we want to find a smarter way of doing this. But here we only need to grab this just as we're starting our scene. So I'm going to go ahead and add some more global variables. I know that because I'm dealing with movement here, I do want to create things that control like my speed, things that would control my jump, things that would even, allow us to store what our velocity is falling on that y-axis or jumping as well. So let's start out with speed. So set up a public variable that I can set and tweak out in the inspector called speed, and we'll give it a starting value of 10 like this. And then the next one we're going to do is going to be our jump height. So we'll do another public. This one will also be a float. And again, we want to set it up here in a public way so that we can adjust these later on. Let's go ahead and add vector 3 that's going to handle our velocity. And actually, this doesn't really need to be public. It can be public for some debugging we're doing, but in this case, we're just going to set it private. We're only really ever dealing with this as a way of keeping track of what our movement is on that y-axis. And then the last thing I want to add here is just a little multiplier. So this multiplier is going to take whatever the world's gravity is and multiply it and give us just a heftier kind of fall. And this is often the case in games that we don't really rely on realistic gravity. So we're not being pulled down by forces as they would be in the world that we exist in. We actually expect, we're sort of like trained to expect like a meteor or a snappier kind of gravity. And so by doing this, instead of adjusting the gravity out in our game's physics, we can do this in the player and give this player like a very specific, like highly tuned kind of behavior on that y-axis. And then we can adjust other things out in the space as well with their own modifiers as well. And these are all the things that I really need to add here. Is just a set of things to get us moving. And so I'm going to head down into update. We're not going to be dealing with physics here. We're going to really be just like simulating things, even our falls. They're going to rely on the physics gravity in the space, but we're only going to be using that as a number which is modified. So we don't have to worry so much about using a fixed update versus an update. We're going to adjust the time with delta time to be able to compensate for any differences in hardware that might be running these games, though. So the first thing we want to do is we want to get the direction of movement, and we're going to do this on two axes. We're going to do this on our z-axis, so our forward and backward movement, and then we're going to do this on our x-axis, which will handle like our strafing here. And so we're going to store these in vector 3s. I'll call this one move z. This will be my forward and backwards movement. And what I want to do is I want to take my transform. This is transform with the lowercase t. I want to get that forward vector. I want to be able to see which way I'm facing toward here. And this is really helpful for us because we're intending to use a mouse as a way of directing the camera and moving toward that. We want to make sure that we're always moving toward whatever we're going to be looking at. So we want to make sure that's relative to the local rotation of our object. And so I'm going to multiply that by our input .get axis. And this one is just going to be using the vertical axis. Okay, so we're going to multiply those things together. Then I'm going to do the same thing for my x-axis as well. Let's call this one move x. And same thing, except we're going to say this time, instead of our local forward position, we're going to say this is our local right position. And we're going to take that and multiply it by our input on the horizontal axis. And then we're going to take those two things and we're going to create another vector here, another vector 3. And we're going to go ahead and sum that movement together. We're going to add those together. Let's call this move. And let's say that this is going to be move z plus move x. And we're going to go ahead and multiply that by our speed, right? So we want to make sure that this is not just a range of -1 to 1, but we want to make this something relative to how fast we want to move through the world. Now, we're going to go ahead and do our physics simulation now. And the way we do this is we're going to take the velocity vector that we've created here. We're going to take the y parameter of it, and we're going to set that so that it is, it has the forces of our world's physics, which we can get by typing in physics.gravity, and we're only interested on the y-axis here. And then we're going to multiply that by our gravity multiplier. and then we're going to take time.delta time, just to make sure all of that is happening relative to your own hardware's capabilities. So we're taking that, we're going to adjust that every frame, right? We're going to always make sure that gravity is pulling us down. We're going to make one exception to that, which is later if we're grounded, we're going to go ahead and set that back to 0. Then what we're going to do is we're going to take the y field of our move vector here, and we're just going to set it so that it's equal to our velocity dot y. Right? So we're just simply taking that and throwing it into this move vector. Now let's go ahead and apply that movement. So we have our character controller, and I'm going to go ahead and take that and call it character controller right here. And we're going to access the move function that's connected to it. There are actually two different ways that we could access this character controller. One is by using move, and one is by using simple move. Move allows us much finer tuned control over the character controller's movement. Simple move does just like it says. It provides a lot more things out of the box, but it really is more limited in terms of what we're able to do overall with it. And so in this case, we're just going to use move and add the physics, the simulated gravity here on our own. And so we'll say now that we're planning on moving this, the vector 3 relative to the motion we want to give it. In this case, we know that we're saving the motion in our vector 3 here called move. And we're going to take that, and again, we're going to take that and multiply it by time.delta time, just to compensate for any differences in computer hardware that might be running this. As I mentioned, what we're going to do now is we're going to take that y velocity and just stop it if we're already grounded. Our character controller, as I mentioned earlier, includes a way of checking for grounding, so we don't have to do any kind of line casts or ray casts or anything like that to check for this stuff. We can just simply say if character controller dot is grounded, and then we're just going to set our velocity to 0. And the reason is we just, we're going to be doing some math to this stuff. We don't want to just keep numbers hanging out in there. We want to just zero it out. And there we go. So we've got our velocity set back to 0 when we're grounded. Okay, now we're going to just create a very simple jump. And so to do that, we're going to take a look at our input for get button down, right? We want just kind of like a momentary button press here, and we're going to use the jump button to do this. And then we're also going to check to see if our character controller is grounded, right? We don't want to be able to just jump while we're in midair. And so if that's the case, we're going to create a jump. And so we do that by saying our velocity dot y is going to have the jump height added to it. And we could do all sorts of things to kind of smooth this out or to make it just feel a little bit better. We can tweak that, but this is the most simple way for us to really be able to get to what we're trying to accomplish. And so let's head back now. I'm going to save this, and I'm going to go back to Unity. Okay, and we'll look for any errors here in our console. It all looks good. I'm going to check my script here. You can see that the things that I've set public, speed, jump height, gravity multiplier, they all look like they're set. Let's give it a shot and see what happens. Good, it appears to be moving as expected. Let's try jumping. Excellent. Great.